All right, when we're adding and subtracting fractions, can we add them the way they're currently written?
No.
Why not?
Because there's not. They don't have the same denominator.
We need to have a common denominator. And to find a common denominator, I know Andrew knows what it is right now, but we're going to go through all the steps and slowly show you how to find each one of these. These problems may appear after we get back from Thanksgiving break on an assignment. So keeping them or keeping track of them might be a great idea. To find our common denominator, we're going to take our two denominators. Lizzie, what's the denominator in the fraction 1/5? 5. Lizzie, what's the denominator in the fraction 1/2? 2. Okay? So our denominators are 5 and 2. And what we have is we are adding 1/5 plus 1/2. 1/5 plus 1/2. So we're adding those two pieces together. We're adding those two pieces together. We have to find a common denominator. To find our common denominator, we are going to list the multiples. We're going to list the multiples of our denominators. Okay, so as we go through this, think of multiple. You can look at multiplication chart. So as we go through it step by step, is 5 a multiple of 2? No. So we have to do one more here. What's 5 times 2 here? 10. So if I went through my multiples with a larger one, is 10 a multiple of 2?
Yes.
Yes. Because it'd go 2, 4, 6, 8, 10. So my least common denominator is 10. Meaning I'm going to change both of these so that they have a denominator of 10. Now, I cannot change the value. You're right, there were 10, so there should be 10 groups. Find a group. You're not done. Okay, so now we have 1/5. And we need to change 1/5 to a fraction that has a denominator of 10. But now, Delaney's always telling me, Mr. McMurdo, if you multiply something by 1, it doesn't change what the value is. Did you know that, Mr. McMurdo? I said, yeah, hi, my name's Mr. McMurdo. What's your name? It's Meet the Teacher Night. Why are you telling me this? Because she's always, she's always been creepy. So I said, yes, Delaney, I know if you multiply something by 1, it doesn't change the value. So Delaney, knowing that, what would I multiply 1/5 by to give me a denominator of 10?
10.
No.
Oh, wait, no.
5 times what is 10?
5 times 2.
Good. So I have to multiply by a fraction, 2 over 2, which tells me that 1/5 is going to equal what?
I know. A lot of chocolate.
Jesse?
It's going to be 2/10.
Good. 1/5 is going to equal 2/10. These are equal.
I don't believe you.
Well, let me prove it. 1/5 is right here. That equals 2/10. Same value. I'm not changing the value. I'm changing how it's written. All right, now I need to change 1/2. 1/2 into a fraction that has a denominator of 10. Now, as Delaney told me, Mr. McMurdo, if you multiply a number by 1, it really doesn't change the value of that number. Did you know that, Mr. McMurdo? And I'm like, yeah, I did, duh. I've been teaching for a while, I know that, Delaney. Alright, so now we need to change 1/2 so that it has a denominator of 10. 1/2 so that it has a denominator of 10. So, Hannah, what would I multiply by here?
5.
5 over 5. Because as Delaney tells me frequently, if a fraction has the same numerator as denominator, it equals 1 whole. If I take 3/3, because each one of these is a third, If I take 3/3 and I put it up here, that equals 1 whole. So I'm multiplying this by 1 whole. So Hannah, what is my numerator here going to be? 5. So I have 2/10 plus 5/10. I always rewrite my sign and bring it over, because if you don't, you're going to get confused. There's 2 or 3, ladies. 2 or 3. Now, as Professor Ham just told us, oh, Professor Burger. I thought it was Professor Ham.
You made me hamburger.
Okay? As he said, we just, oh, wait a minute, let's prove. 1/2, we said equals 5/10. I just don't believe you unless I see a picture of it. So 1/2 is going to be the same value as 5/10. We have found our common denominator. We have 1/5 plus 1/2 equals how many tenths? 7/10. 1/2 plus 1/5 equals 7/10. And we proved it with our fraction strips. I know you all have fraction strips, because I know you've all been given fraction strips, because I was the one that has given them to you.
What a kind teacher you are.
Yes.
What a very kind teacher. Yeah, it is.
Yes. All right, so let's look at another one. We probably should be not having all this talking, especially if I can send it to your parents and they can hear your voice on there when you off task. So let's look at the next problem. Let's look at 2/3 plus 1/6. 2/3 plus 1/6. So this is what we have. 2/3 and plus 1/6. We're putting those together. Benjamin, can we add these fractions as they're currently written down? No. We need to change them so they have a common denominator. We have the denominator of 3 and 6. And if I list the multiples out, I get 6, 12, 18, 24, 3, 6, 9, 12. What do they have in common? What's the first number they have in common? 6. 6. So I need to change these so they're both over 6. They do have 12 in common. But that's not the least common. So, yes, this is going to have 3. 12 is also a multiple of 3. 18 is also a multiple of 3. 24 is also a multiple of 3. So we're going to have an infinite number of multiples in common, but we're looking for the least one they have in common, which is 6. So now 1/6 is already 1/6. So I can, if I use my denominator, 1/6 is equal to 1/6. You see how those are equal to each other?
Yeah.
How cray-cray is that? Cray-cray. All right, now I need to change. Now I need to change 2/3 into something with a fraction of 6. Now, I don't know if I've told you this, but I have a student named Delaney who's always like, you know, Mr. McMurdo, if you multiply or divide a number by 1, it doesn't change its value. So we're going to multiply this by 1 so that I get a fraction that equals 1 to give me a denominator of 6. So Hannah, what would I fix? 2 over 2. Because, as we've proven before, 2 halves equal 1 whole. Those two are equivalent. 2 halves equals 1 whole. All right, so Hannah, 2/3 times 2 over 2 equals how many 6?
4.
4/6. How did we get 4? Because when you multiply fractions, you multiply straight across.
Oh. So you do the top of it? Yes.
Yes, you do both.
Oh, you do the top of it? Oh. That's where we messed up.
And now we're proving that 2/3 is the same as 4/6. Because 1/3, 2/3. So 1/3 equals 2/6. 2/3 equals 4/6. So I'm saying 2/3 plus 1/6 as the same as saying 5/6.
You said 3/6.
But she subtracted instead of adding. No, you can't do it diagonally. All right, let's look at some subtraction. Hopefully you're writing these down. This one's going to be for subtraction. We have the problem 1/6 subtracted from 5/9. Hopefully you have that down. 1/6 subtracted from 5/9. Let me give you a minute. I want you to see if you can figure out what the least common denominator is.
I got it. Oh yeah, I found it. What?
Tucker, since you're talking, I'm going to assume you know the least common denominator. If you had a multiplication chart, you could look at it. Do you have it? Well, get it out. Don't just stare at me. Shh. Your names are not Tucker, so put your hands down. All right, Tucker, let's look at your multiples of 6. Shh, the rest of you are quiet. I'll give you a chance to work together in a moment. Tucker, tell me the first 3 multiples of 6. Look at your multiplication chart. Good, 6, 12, 18. Tucker, tell me the first 3 multiples of 9. 9, 18, 27. Tucker, have we found a least common multiple yet? What? 18. These both have 18 in common, meaning my least common denominator is going to be 18. I don't have no 18th pieces, so I can't show you on pictures. All right, as my friend Delaney tells me, you know, Mr. McMurdo, if you multiply or divide a fraction by 1, it doesn't change like the value. Okay, so now I need to select a fraction that equals 1 that I'm going to place here that would give me a denominator of 18. And I need to select a fraction that equals 1 that I'm going to place here that gives me a denominator of 18. So take time, take a minute and think. So Jesse, looking at 5/9. Looking at 5/9. What would I multiply by here to get 18?
2 over 2.
2 over 2. Now Jesse picked the fraction 2 over 2 because 2 over 2 equals 1. Jesse also learned yesterday that when you multiply fractions, you go straight across. So 9 times 2 is 18. 5 times 2 is 10. And Hannah's either trying to touch the ceiling or she wants me to call on her. So Hannah, I have 1/6. I need to equal something over 18. So what fraction that equals 1 should I choose? 3 over 3. So I have 6 times 3 is 18. 1 times 3 is what, Hannah? 3. Good. So now I have 10/18 and 3/18. 10/18 and 3/18. Christopher, what is my final answer?
7/18.
Oh, 7/18. Because it is subtract. Now I'm going to tell you right now where you're going to miss most of your problems on this is not moving your sign over. And then you're going to make those mistakes and think it's adding when it's supposed to be subtracting. Oh, are you writing it down on this? All right, so you should have this written down. I'm going to go to another subtraction problem. Because in a moment, when I ask you guys to do it on your own, you're all of a sudden going to look at me like I've never taught anything about fractions.
I think you have it. He's doing it right now.
Write this down, and in a moment I'll call on someone to tell me the least common multiple.
Correct answer. It's name. No, it is not. It's not 78.
Oscar, what are my denominators for 9 and 3? What are my denominators for 8/9 and 2/3? What's the denominator of this fraction? What's the denominator of this fraction? Okay, so those are my two denominators. 9 and 3. Tell me my first 3 multiples of 9, Oscar. Okay, the first 3 multiples of 3.
6 and 9.
Okay, do they have anything in common, Oscar?
No. Oh wait, the 9 and the 9 and the 9 and the 3.
Good. The 9s. The 9s are our least common denominator. Yes, if I keep going, 18 is a multiple of 3. I can keep going with my 3s, and every one of these is going to be a multiple of 3. They will. So I can't ask for the greatest common multiple because you can't give it to me because it goes on infinitely. Forever. For infinitely. Okay, so now we need to change both of these fractions so that they have a denominator of 9.
Teachers, pardon the interruption. There will be a 10-minute delay in all lunches. 10-minute delay. Thank you.
All right, so let's, Oscar, when you get done being pouty about 10 minutes, let's look at this. Do I need to change anything here? No, because it's already over 9. Oscar, do I need to change anything here?
Yes.
Yes, because it's over 3, and I need to change it so that it's over 9. So I need to multiply it by a fraction that equals 1. Remember, Oscar, a fraction that equals 1 has the same numerator as denominator. And when I multiply fractions, I multiply straight across. So that fraction must have what as the denominator? 3. And for it to equal 1, it has to be 3 over 3. So now, Oscar, multiplying straight across, Oscar, what is my numerator? 6. So we have 8/9 and 6/9. Rocky? Equals 2/9. Because yes, it is subtraction. Okay, I'm going to tell you right now, fractions are very, very easy. The difficulty with fractions comes in it takes a lot of steps. It takes a lot of steps. Are you guys passing notes? How cute. It takes a lot of steps, and it's not that you can't get it right, it's just that sometimes you get lazy and don't want to get it right.
That's not me.
Or you say, no, I wanted to get it right. No, you don't, or you do the work. But, that's just me saying that. But now there are some problems that can be simplified. So let's say we have this following fraction, or this following problem. I'm making this up. We don't have to find a common denominator. But let's say we have 7/10 plus 1/10. Okay, it's got a common denominator. I can do it like it is. So what is 7/10 plus 1/10? 8/10. Okay, so it's 8/10. I know last year you learned how to simplify fractions. You can't leave them in a form that can be made simpler. And I'm going to show you how it can be made simpler, and I'm going to show you the picture of it to make it simpler. We've listed factor pairs. When we decided to find prime and composite numbers, we listed factor pairs. So we're going to look at the greatest common factor for my numerator and denominator. We want to find the largest number that they have in common. So I list my factor pairs for 8. So 1 and 8, 2 and 4. 10, 1 and 10, 2 and 5. What kind of number is 8, prime or composite? Composite. Because it has more than just 1 in itself. All right, so what is the greatest number that shows up in both of these lists? Hannah? 2. Good. They have a 1 in common, and they have a 2 in common. Therefore, the greatest common factor is 2. It is. So now, what do we do with that greatest common factor? For as a reminder, for as what you did last year, you simplify that by dividing both the numerator and the denominator by that greatest common factor. Because, as a friend of mine named Delaney once said, Mr. McMurdo, if you divide a number by 1, it doesn't change the number. It just changes the way it's, written. And so, same with multiplication. We're going to divide straight across. 8 divided by 2 is? 4. 10 divided by 2 is? 5. So what I'm trying to tell you is 8/10 is equal to 4/5. Well, prove it, Mr. McMurdo. I will. Don't yell at me. Okay, I'm sorry. I didn't mean to yell. Thank you. All right, so we have 8/10. So let's get 8/10 here. 2, 4, 6. You're right. But it's the same value. 8/10. Okay, we have 8/10. Some bozo's trying to tell me that is the same value as 4/5. And boom, shakalaka it is. Boom, shakalaka it is. Now, Tucker, that's a good question. Tucker wants to know, why do we even have to simplify? That's a great question, Tucker. Let me explain to you why. A lot of times, simplifying makes them easier to visualize in your head. If I said, all right, I want you to picture a pizza that's cut into halves. You could pretty much do that, right, Tucker? You could say, oh yeah, cut it vertically, pepperoni on each side. All right, I can visualize that. But what if I told you to visualize a pizza that was
1 million.
cut into 500 pieces and you ate 250 of them? That's harder to picture, isn't it? But these are the same value. 1/2 and 250 over 500. Those are the same value. But now you can kind of see what, instead of, if I simplify that down, it makes it a lot easier for me to understand. Also, we want to speak a common language in math. A common language in math. So if you're thinking 250 over 500, and I'm thinking 1/2, we both are right, but we might get into a fist fight because I'm saying the answer is 1/2. She's saying the answer is 250 over 500. We disagree. So, drop the mic and let's go. That's what happens, and nobody wants that.
Drop it.
Ain't nobody got time for that. Okay? Because there'll be nothing but tears.
From Mr. McMurdo.
Probably tears for Mr. McMurdo. All right, let's look at another one. Did we do 8 9 plus 2/3 yet?
Yeah.
We did? All right, let's do 5/7. Subtract 1/2. 5/7. Subtract 1/2. I'm going to give you a minute to think, and then I'm going to probably call on someone that just sits there and doesn't do any work and just kind of rides the coattails of the rest of the class. I'm going to call on one of those people to tell me what the common denominator is. The least common denominator. So if it were me, and I thought, you know what? I'm a bit of a bozo. He may call on me. I would, instead of trying to hide under my desk thinking my teacher's an idiot, I might get out my multiplication chart and look down the 5 row and the 2 row, or I'm sorry, the 7 row and the 2 row and see if I can find a number that shows up in both. All right, so Anton, Reed wants you to stop talking so you can figure it out. Savannah. Savannah, what is the least common denominator for 7 and 2?
14.
14. 14. So what Savannah's telling me is I need to take my 5/7 and instead of 5 groups of 7, I need to put that same amount into groups of 14. So Savannah, what fraction would I put here that equals 1? 7 times equals 14. 2. Because, as my friend Delaney said, Mr. McMurdo, you know, if you multiply something by something else that equals, like, 1,
How many times can you say it to him?
then you know that if you do that, you don't change the value. You're just, like, changing how it's written. It's like me nicely giving Scarlett $1, and then, being fair, I want to give David the same amount, so I hand Scarlett $1, and I take a roll of 20 nickels, and I throw them as hard as I can at David. That's the same value. That's the same value.
It's just shown in a different way.
It's just, one is shown with love, and the other one is shown with
hatred.
something that would make me laugh. Okay, so Savannah, what would my numerator be? 10. Now, as my friend Delaney told me, you know, if you multiply by a fraction that like equals 1, it doesn't change like the value of like the first like fraction. So, Savannah, 7 over 7.
Savannah, 7.
Because the fraction 7 over 7 equals 1. Now again, I'm going to tell you that saving this sheet is going to save you lots of time the week we come back from spring break, or Thanksgiving break, sorry. The week we come back from Thanksgiving break, because your teacher, don't tell him I told you this, but your teacher is going to give you an assignment,
No.
and 10 of the 15 problems on that assignment are going to be from videos that are recorded today. But don't tell your teacher that I did this for you.
I can tell you something that we can't tell you.
Savannah, what goes here? 7, thank you. Shh, hands down. All right, Savannah, we have 10 14ths and 7 14ths. What's my answer?
17.
Wrong! This is why. It is a subtraction problem. All right. Listen. I am so glad you did that. Because that'll be a mistake that is made frequently if you don't pay attention and move the sign over.
Wait, you're glad
Matthew.
Wait, but that's
I know. It's been upside down.
Why are you glad that I did that?
No, she asked me, why am I glad that she did that? Because I wanted to be able to demonstrate to the class that if you don't focus on moving your sign over, you make mistakes.
Well, it's because
And if I were making this a multiple choice question, one of my top 2 answers would be 17 14ths. And boom shakalaka, I'd get half of you to pick it, and then I would be winner, raw chicken bubblegum. Because that's the way I am. No, that's not the point. I don't want you to get it wrong. I want you to pay attention.
I forgot.
No, I'm glad you did it. All right, let's look at our next problem. And I'm going to give you a moment to find a common denominator.
Can you call us up?
No, because I'm recording.
So many people were saying it was 17.
Are you finding your common denominator?
Oh, I already did that problem. I did all of it. Did you add all of them? No! Wait, I can't.
All right, so Christopher wants to know, why did you write it like, or put the tiles up like this? 3/4 and 1/6. Well, Christopher, this is a subtraction problem. So I want to take this much off of 3/4. So the answer I'm actually looking for, Christopher, is going to be right here. This space is going to be the answer I'm looking for. That space right there. Okay? So when it's subtraction and you're using your fraction strips, then you're going to put the second number down below. The number you are subtracting down below. All right, so we've had a minute. We've seen our denominators are 4 and 6. We've looked at our multiplication chart to find the least common denominator. And Andrew, what is my least common denominator for 4 and 6? 12. Anybody have a disagreement with that?
Wait, no.
Okay. It is 12. But another way they're going to ask you to do on an assignment that you're going to start in a few minutes, another way to find a common denominator is I could just multiply 6 and 4 and put it over 24 too. I could do it that way, but then I'm going to have to more likely simplify. So Lizzie's figured out the answer. Hey, you know Lizzie? I had a student one time that on Meet the Teacher night said, "Yes, you know her?"
Yes, she's right there.
This student came up to me and I said, "Hi, are you in my math class? I'm Mr. McMurdo." She said, "Hi, Mr. McMurdo. Did you know that if you multiply a number by like 1, it doesn't change the value?" No. I learned it from Delaney.
Boy.
Lizzie, what do I multiply by here? 3/3. Because as my friend Delaney said, Mr. McMurdo, 3/3 equals like 1. Look, Mr. McMurdo, 3/3. 1/3, 2/3, 3/3. That's the same as saying like 1/2. Those are the same value, but it's upside down. Doesn't matter. It's still 1/2. It's 1 pizza where the guy accidentally flipped it over when he gave it to you and you got it for free, but you could still eat it because it was still tasty. And Lizzie, what is my numerator here? 9. 9 12. Okay, so now we're talking too much. Delaney, you're still talking too much.
Yeah, Delaney. She was telling everyone.
I could take my 9/12 and it would equal up right above there. Now, Lizzie, did you know that if you multiply a number by something that equals 1, you don't change the value?
Yeah, I thought Delaney said it.
Delaney did tell me that. So what do I multiply by here?
2.
2 over 2.
That's equals 1/2. What'd you say, Mr. McMurdo?
I don't remember. So now I have 9/12, subtract 2/12, and I get what, Laney? 7/12. Or Lizzie, sorry.
You love me, Laney.
Now, wait a minute. Mr. McMurdo taught us that sometimes you have to simplify fractions. He gave us a fraction. He told us had to be simplified. But how do we know if it has to be simplified? Very good. Anna says we find the greatest common factor. Okay, eyes up here. Eyes up here. All right, in order to find out if a fraction can be simplified, you take both the numerator and the denominator and you find the greatest common factor. What are my factors of 7? Hannah? Excellent. 1 times 7. Are there any other factors of 7, Hannah? No, good. No, because it's a prime number. I know it's a prime number, and if I didn't remember, I could always look on my journal. Okay.
He gave us 100 tries.
Okay.
He's the greatest teacher.
Hey, Reed,
Sir.
can you tell me the factors of 12? 1 and 12, good. 2 and 6, good.
3.
And 3 times 4, good.
He's very good.
1 times 12 is, or 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Now, what do they have in common? They have a 1 in common. If all they have in common is a 1, that means it's already in least common terms. It's simplified all the way down to the lowest point it can be simplified. Questions? Let's do one more before I turn you loose.
12 minus 1.
Okay, Anna just asked me if I do a problem of her choosing. 6/12 minus 1/3. So I'm going to do the problem that Anna selected. I'm going to give you a minute and I want you to think of the common denominator. Scarlett, what is our least common denominator?
6.
No, not 6. Look at my multiples of 12, my multiples of 6. 12, 24, 36, 18. They have anything? What's the first number they have in common? No, it's 3. Sorry, my bad. 3, 6, 9, 12. Hey, sit down. Quit yelling out. 12 is our least common denominator. Okay, this is already 6/12. I need to multiply this by 4 over 4 to give me 4 twelfths. 6 twelfths subtract 4 twelfths is 2 twelfths. Now I need to see if I can simplify 2 twelfths. See, nothing that we do in fractions is beyond your ability to do it. It just is, do you want to go through all the steps or would you rather get it wrong? So let's find our greatest common factor for 2 and 12. You want to get that, Oscar? Taylor, what are my factors of 2? No, those are multiples. 1 times 2. Okay, my factors for 12 are what, Taylor? 1 times 12. 6. 3 times 4. Good.
Miss Kirby needs a calculator.
A calculator? All right, there's one over here you can take to her. Get one out there and take it to her. All right, so now you're going to get this wrong when you do this assignment. We find our greatest common factor, which in this case is 2. Since my greatest common factor is 2, my answer is 1/6. And I can show that again because 2 twelfths is the same as, do I have 6? Yes, 1/6. So those are the same values. Savannah? Not right now. Any other questions about these? Awesome sauce. Need your textbooks out, please. I need you to open up to page 219, please. God bless you.